Assalamualaikum and hi everyone. Welcome to the last video for topic 1 limits and subtopic 1.1. The learning outcome for this video is at the end of the lesson, students should be able to determine the existence of the limit of a function. How to determine when limit exists? So, the first thing, we are going to look at this animated graph. We are given limit of fx, x approaches a from left is L. It means fx or the red graph is moving towards a value of L as it gets closer and closer to the value of x equal to a from left and stop at the point AL. We are also given limit of fx, x approaches a from right is L. It means fx or the blue graph is moving toward a value of L when it gets closer and closer to the value of x equal to a from the right and stop at the same point AL. Therefore, in this graph, we notice that fx approaches the same value. It is L when fx is moving closer and closer to x equal to a from both directions. In order to see the limit exists, the function fx has to approach the same value regardless of which direction x comes from. Thus, we can state since limit of fx, x approaches a from left equal to limit of fx, x approaches a from right is L, then limit of fx, x approaches a exists or the limit value is L. Next, how to determine when limit does not exist? So, we are going to look at this animated graph. We are given limit of fx, x approaches a from left is equal to L. It means fx or the red graph is moving towards a value of L as it gets closer and closer to the value of x equal to a from left and stop at the point AL. We are also given limit of fx, x approaches a from right is equal to m. It means fx or the orange graph is moving towards a value of m when it gets closer and closer to the value of x equal to a from right and stop at the point am. So, in this graph, we notice that the one-sided limits, it is the left-hand limit and the right-hand limit both exist, but they are not the same value. Or, in other words, the function or the graph jumps at x equal to a. Then, the limit does not exist. This is usually written as since limit of fx, x approaches a from left is not equal to limit of fx, x approaches a from right, then limit of fx, x approaches a does not exist. Then, we can conclude that limit of fx, x approaches a exists if and only if limit of fx, x approaches a from right, and limit of fx, x approaches a from left, both exist and are equal. Or it can be written as, if limit of fx, x approaches a from right, equal to limit of fx, x approaches a from left, equal to L, then limit of fx, x approaches a also equal to L. It means limit of fx, x approaches a exists. Okay, example 12. Let fx is equal to x plus 1 when x is greater than 0, and fx is equal to x minus 1 when x is less than 0. Verify the existence of limit as x approaches 0. As we already know, limit exists if and only if the right hand limit and the left hand limit both exist and are equal. So, to solve this example, first we need to find limit of fx, x approaches 0 from right, and limit of fx, x approaches 0 from left. Then check whether both limit exist and are equal or not. Okay, so now let's try example 12. Okay, we are given this piecewise function fx equal to x plus 1 when x is greater than 0, means fx is defined for all values of x on the right of x equal to 0. Okay, so the inequality greater than show right limit. Then fx equal to x minus 1 is defined when x is less than 0 or the sign of inequality less than. Show that or show for limit from left. Or if you have problem to choose the correct function, it's better to draw the number line as usual. Okay, where 0 here is referred to the domain or to this number. Okay. Okay, so for x greater than 0 is on the right of 0. So the function is fx equal to x plus 1. Okay, and then for x less than 0, so it is on the left of x equal to 0. And the sign, the inequality is x less than 0. Okay, so why both are empty circle? Because the inequality has no equal. Okay, so for the left function is x minus 1. Okay, so now we need to find limit of fx, x which is 0 from right, and limit of fx, x which is 0 from left. Okay, so the first one is limit of fx, x which is 0 from right. Okay, from right. So we refer to the right of x equal to 0. So here, the function of fx is x plus 1. So we replace fx by x plus 1. Okay, then substitute x by 0. Then we get 0 plus 1. So the limit of fx, x which is 0 from right is 1. Okay. Then we find limit of fx, x which is 0 from left. Okay, so use refer to the left of x equal to 0. And here we notice that the function is x minus 1. Okay, so we replace fx with x minus 1. Then substitute x equal to 0. We get 0 minus 1. And the limit of fx, x equal to 0 from left is negative 1. So here, we notice that limit of fx, x equal to 0 from right, is equal to 1. Limit of fx, x equal to 0 from left, is equal to negative 1. Both exist because they have value, but they are not the same value, which is a requirement for the limit exists. So we can conclude that since limit of fx, x equal to 0 from right, is not equal to limit of fx, x equal to 0 from left, then limit of fx, x equal to 0 does not exist. Example 13. Given fx equal to x squared when x is less or equal to 2, fx is equal to 8 minus 2x when x is greater than 2 and less than 4. Fx is equal to 4 when x is greater or equal to 4. Determine limit of fx, x approaches 2, and limit of fx, x approaches 4. Since we are given a piecewise function, then to get the limit of fx, x approaches 2, and limit of fx, x approaches 4, first we need to find the right hand limit and the left hand limit for both values of x that have been given. Then we check if they satisfy the requirement for the limit exists or not. Okay, so we try to solve this example. Okay, you have a piecewise function, 3 functions in 1 function. So better we draw a number line. Okay, so the first function is fx equal to x squared when x is less or equal to 2. So we draw an arrow line as like that. Okay, here is a dense circle because the inequality has equal. So the function is fx equal to x squared. The second function is 8 minus 2x when x is greater than 2 and less than 4. So the arrow line as shown. Okay, so we use empty circle because for both inequalities has no equal. And the function is fx equal to 8 minus 2x. And the third function is fx equal to 4 when x is greater or equal to 4. Okay. So first, we try to determine the limit of fx, x approaches 2. Then we find limit of fx, x approaches 2 from left. 2 from left. So stay at 2. So on the left 2, okay. So here we notice that the function on the left 2 is fx equal to x squared. So we replace fx by x squared and substitute 2 into the function. So we obtain 2 squared and the value is 4. Next, we find limit of fx, x approaches 2 from right. Okay, so we stay on the right of 2 here. And we notice that the function is 8 minus 2x. Okay, so replace fx and substitute the value of x. So we obtain 8 minus 2 times 2 or 8 minus 4. So the value of limit fx, x which is 2 from right is 4. Okay, so here we notice that both limit exist and are equal. Okay, both have same value. Then we can conclude that since limit of fx, x approaches 2 from left, equal to limit of fx, x approaches 2 from right, equal to 4. Okay, because they have same value, so we put the value. Then, or therefore, limit of fx, x approaches 2, exists. So when exists, you need to write the value. So it is equal to 4. Okay, next, we find or determine limit fx, x approaches 4. So same as the previous, we find limit of fx, x approaches 4 from left. Now we stay at 4. Left. Okay, we stay on the left of 4. So we notice that the function is 8 minus 2x. So we replace fx by 8 minus 2x. Substitute x equal to 4. So we get 8 minus 2 times 4, or 8 minus 8. So it is 0. Okay, next we find limit of fx, x approaches 4 from right. Okay, now we stay on the right of 4. Here, the function is fx equal to 4. So, replace fx by 4. And this one is a constant function. Automatically, the limit value is 4. Okay. So, here, we can see or we notice that both limit exist, but they are not equal. So, the conclusion is, since limit of fx, x approaches 4 from left is not equal to limit of fx, x approaches 4 from right. Therefore, limit of fx, x approaches 4 does not exist. Example 14. The function ft is defined by ft equal to 3t plus b when t is less than 4. Ft equal to 2 minus bt squared when t is greater or equal to 4, where b is a constant. A. Find limit of ft as t approaches to 4 from right, and limit of ft as t approaches 4 from left in terms of b. Question B. If limit of ft as t approaches 4 exists, determine the value of b. Okay, so we try to solve this example 14. Okay, so we try A. Okay. We are given a piecewise function. Okay, so we know t less than 4 is referred to the left of t equal to 4, and the inequality greater than refer of value of t on the right of t equal to 4. Or we can draw number line as usual. Okay, so t less than 4 is on the left of 4. So the function is ft equal to 3t plus b. And on the right of t equal to 4, the function is ft equal to 2 minus bt squared. Okay, so question A, we are asked to find limit of ft as t approaches 4 from right, and limit of ft as t approaches 4 from left in terms of b. Okay, so we find one by one. Okay, the first is limit of ft as t approaches 4 from right. Okay, from right. So you stay on the right of 4. So here we notice that the function is ft equal to 2 minus bt squared. So we replace ft by 2 minus bt squared and then substitute the value of t equal to 4 and get 2 minus b times 4 squared, or it is 2 minus 16b. Okay. Then we find limit of ft as t approaches 4 from left. From left. Okay, stay on the left of 4. Okay, so here the function is 3t plus b. Okay, so replace ft by 3t plus b. Substitute t by 4 and get 3 times 4 plus b, or it is 12 plus b. Okay. Next, we proceed with question B, which the question asks us to find limit of ft. Determine the value of b. Okay. The question asks to determine the value of b if limit of ft as t approaches 4 exists. Okay, so we are given limit of ft t approaches 4 exists. Okay. Then, if limit exists, we know limit exists if and only if the right hand limit and the left hand limit both exist and are equal. Okay, so from question A, yes, we got both limit exist. Okay, but now you have this limit ft as t approaches 4 exists. Then limit ft t approaches 4 from right is equal to limit ft t approaches 4 from left. Okay, why they are equal? Because limit ft t approaches 4 exists. Okay, so from question A, we already have the right hand limit and the left hand limit. Okay, so we just substitute the right hand limit by 2 minus 16b and the left hand limit by 12 plus b. Okay, so we solve. Okay, where we bring b to the left hand side and constant to the right hand side, and we get the left hand side is negative 70b equal to 10, and the value of b is negative 10 over 17.